Hello and welcome to another video. In this video we're going to be working on Flatten nested list iterator. So in this problem you're given a list of integers, nested list, and each element is either an integer or a list whose elements may also be integers or lists. Implement an iterator to flatten it. Implement the class, initialize it, return the next integer in the list, and have hasNext shows if there are still integers in the nested list, if or false otherwise. And here we have our pseudocode. So essentially what's going to happen is it'll essentially just say, while there is an item, let's just keep adding things. And if it works, then we'll have the correct answer. So as an example, nested list here, we essentially want to remove the nesting completely. So we would want to have something like this. And in the second example, for 146, it's also nested, we would want to have 146. So basically, I think there is actually like a LeetCode problem. I think it's in JavaScript that's actually just flatten a nested list. But essentially, the way of flattening a nested list works is pretty simple. So let's just take this example. The tricky part is honestly understanding what this class does and like how to use it. So essentially, what you want to do for a nested list is you want to have some kind of like output array. So we'll just put it over here. And for a nested list, you want to check, like you're going to have a function that will always get a list. And then for every element, you're going to want to check, is it a list or is it an integer? And if it's a list, we want to recurse into that list. And if it's an integer, then we can just output it. So what's going to happen here is we will call this function with this whole thing first. And so we're going to go element by element. So the first element's over here, and we're going to check, is this a list or is it an integer? And it is a list. So we're going to recurse into this list. And then when we're on the first item of this list, we're going to say, is that a list or is that an integer? It's an integer. So let's put that. Is this a list or is this an integer? It's an integer. Then we will recurse back out, right? So we will recurse back out of this, and we'll go into the next element of this like overall list. So then in here, is this a list or is this an integer? It's an integer. And then we come over here to this element over here, and we say, is that a list or an integer? It is a list, so we will recurse. And then in this recursion, we're going to say, is this a list or an integer? Integer, list or integer, integer, recurse back out, and then we're done with all the elements, right? So this overall list had 3 elements, a list, an integer, and a list. And that's essentially it. So that part is pretty straightforward. Now the weird thing is like this thing right here, like reading documentation and understanding what in the world it's like took me a little while. So essentially they're saying you have an interface here that allows for creating nested lists. You should not implement it or speculate it, but you need to use it. So you have a class nested integer. It has 3 functions. It has isInteger, which will tell you if it's an integer or not. And then it has getInteger, which will give you the integer that it holds, or null. And it will have getList, which will give you the list of nested integers. So essentially what's going to happen here is, like, if we draw this again, what's going to happen here is instead of drawing these, I'm just going to write them all as nested list, nested integer items. So what's going to happen here is it's going to look something like this, right? These will all be nested integers. And what you need to do is you need to go, you originally passed this in to your constructor. So your constructor of your class actually takes this list, right? So it takes this list, and then what you need to do is you need to, the way we're going to do is we're going to flatten it to begin with, then we'll just hold the list of integers in our constructor, and then it's very easy to get the next integer and hasNext, right? Because essentially we just have a list of integers. So that part's pretty straightforward. But how do we flatten this? Well, what's going to happen here is we need to make a recursive function that essentially takes in a nested integer list, and we need to check in that nested integer list for every item. So you can iterate through this list. So if you take in this nested integer list, you can iterate through this because these are all objects, right? So this is an object, this is an object, this is an object, right? A nested integer is either a nested integer like list essentially, or an integer. So it'll look something like this. So we would essentially get this, we iterate through and we check, is it an integer or is it a list? And the way we do that is with this isInteger. So if it is an integer, right, and we'll have the same thing, we'll have some result array. So if it is an integer, then we will get the integer and we will just append it to our array. And if it's a list, then we will get the list and then recurse into that list. So what's going to happen, kind of like walking through our recursion here. So our original method call will have this, right? Then we will check the first element. Is it an integer or a list using that method? It is a list. So then we will get the list and we will recurse into this list here. And then for every element, we will check, is it an integer or a list? So here it's an integer. We will put that number into the result. Integer, put that number to the result, recurse back out here. Then we come to this element in the list, check if it's an integer or a list using that method. It's an integer, so we'll use getInteger in that case. Put that into the result. Then we will come here. We'll check if it's an integer or a list. It's a list, so we'll use getList. So essentially, you just keep checking for every element. Is it an integer or a list? If it's an integer, you just get the value, put it into the result. And if it's a list, then you recurse, you get the list and you recurse into that list. That's the easiest way to do it. And then we'll just have a list of numbers. So like, let's say we have a list of numbers, like 1, 2, 3, like we'll have just like a normal list. Then for has next, the next is very easy, right? We have a list, we have an index, and we can simply check like, is our index in range? If it's in range, let's get the number and let's move on to the next index and so on. Like that's like super, super easy, right? Essentially, we're going to flatten first in the constructor. We're going to have a helper function that will help us flatten, and then doing the rest of it will be super easy. But yeah, once you understand that like this getList returns an iterable object that we can loop through to get everything, it's pretty straightforward, but this is kind of difficult to understand. So now let's actually use that and let's code up our solution. So here we have it here. So what we are going to do is we are going to actually initialize our, so we're going to have a helper function here. So let's actually define that first. So we'll call this maybe like def, I don't know why, there we go, def flatten. And it will just take a list of nested integers, right? Actually, we'll just call this like nums or something. So which will be a list of nested integers, basically. Now we're going to have a result, and we're going to have a, in this flatten, we're going to write another function. So this flatten will actually, in practice, take a list of nested integers, which will be called nums, and then we're going to have another function here that needs to actually recurse, right? You need to declare this result outside of flatten, or you can declare it in like the actual arguments, but I'm going to declare outside because I'm going to be pushing to it. So I'm going to have another function here called like def whatever you want, right? Like nester or something, I don't know. And this function is going to take nums as well, so it'll in practice be a list of nested integers. So now we need to do a couple things, right? So we need to check for every, so this will be an iterable object of nested integers. So we could say for num in nums, even though these aren't really numbers, these are nested integers. So for num in nums, if we need to check, is it an integer? So if num is integer, right? These are nested integer objects. If this is the case, then we can just take that value and append to the result. So we can say res append num dot get integer. Otherwise, it's a list, but we can't access the list directly, right? It's a nested integer object, so in order to get the list of the things in it, we have to do this get list. So we can say else nester, and then this is going to be num dot get list, right? So essentially, if this is a list, we have to actually get that list. It's an object that has a list of nested objects in it. That's why this format's really weird. In order to get it, you have to do get list, and then you recurse into that. That should be it now. Now we should just be able to return the result. And so now this result will be an array of numbers that will just be normal numbers. So now we could say self.numbers or something equals self.flatten, and then we can pass in this nested list. So now that we have these numbers, now it's really super straightforward. Now we just have like a self.index as well. We'll start at 0, right? Now the rest of these are super easy. So we'll just have like result equals self.numbers at the index we are at, and we just increment the index, right? And has next, also super easy. We just check if our index is in bounds, right? So return self.index is less than self.numbers. Right, so if our index is in bounds, it needs to be less than the length of our numbers, then this part will be true. Yeah, so these two functions, super easy. It's just like flattener that you need to understand. And like I said, there are actually problems in LeetCode that actually just flatten an array without using this weird object. I'd try using that first if you still don't get that. But yeah, that's the confusing part, is like understanding this that returns an iterable list that you can actually traverse. And yeah, let's see what happens here. Hopefully we don't have any errors. Looks like we do not. Oh, we just have a wrong answer. Okay, we probably just never called our function or something. Yeah, so it looks like we never called it. So we're gonna call Nestor with the initial nums that were passed in from Flatten. Yeah, let's see, local variable index, self. All right. Okay, we have a bunch of nulls. That's not good. All right, so to get the actual value, you don't do get integer. You have to do, actually you do. So let's take a look. If num is integer, yeah, so we got a bunch of nulls in here instead of actual values, which is a problem. So let's actually, so I think the problem is, let's double check this again. So def nestor nums for num in nums. If num is integer, res append num get integer. That part should be fine. Let's actually print this. Okay, so the numbers seem to be correct. Yeah, so we have some kind of like index error or something along those lines as to why our output is null. Oh, right, we never return. Okay, so return result. There we go. Okay, there we go. And as you can see, it's reasonably efficient. So let's talk about the time and space. So for the time, essentially, however long this thing is, you're basically going element by element. So this is going to be like O of n, roughly, where n is the length of nested integers, regardless of the nesting, right? The nesting isn't going to affect the time. So to flatten will be O of n, where it's the length, and then these are both O of 1, right? We're just getting a number. So flatten O of n, these O of 1, and for space, so for flatten, there are other ways of doing this, but if you think about it, worst case space complexity should be the same for all of them, because if your numbers are like this, right, where it's like 1, and then it just keeps nesting essentially, right? So it's like 1, and then 2, and then like you just have like a ton of nesting where it's like an array of arrays of arrays of arrays of, you know, whatever. If you keep nesting and nesting and nesting, it's gonna get pretty bad. So essentially what it is in our case, it's actually the I think actually it might be a little bit more efficient if you use something else, because ours is going to be O of n, where n is the number of numbers. Like your worst case nesting, in each array you'll have like one number or something, right? I think it'll actually look like something. I'm trying to think of like what would be worst case. It'd probably be like 1, comma. Yeah, I think it would be something like this, right? So you'd have 1, comma, and then you'd have like another array 2, comma 3, comma 4, comma 5, and so on. Something along those lines, where the depth is going to be equal to the number of elements, which would be O of n. So technically, worst case, I think no matter how you do this, worst case is O of n if you do flattening. But realistically, if you use something else, it's going to be O of the depth, where in our case, it's always going to be O of n, because we are storing the numbers. So there are, like I said, there's other ways to do this. You can make a generator or some other stuff. But this is pretty straightforward, and it's pretty good. And then as far as for next or has next, that's going to be O of 1. So our worst thing here will be this numbers. And yeah, that's going to be all for this problem. So hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I will see you in the next one. Thanks for watching.